Hello, everybody. This is Mr. Kusaj, and we're up to lesson 8-2. Don't forget the date here. Vectors in the coordinate plane. So we talked about what a vector is, basically an arrow with magnitude and direction. Well, now we want to express the vector in a different way. It's called the component form. Okay? So from now on, we're not going to necessarily see a diagram, right? A picture of a vector. We're just going to see 2 points on the coordinate plane, right? And then with those 2 points, we can figure out the A and the B. For example, here's a vector in the coordinate plane. This is 0, 0. This is 3, 2. So with some math, we can just say that the components of this vector are 3 and 2. But you could have the vector between any 2 points. To get the component form, all you do for that vector is subtract the second x by the first x, the second y by the first y. So this minus this minus this. Okay? And those 2 answers will give you the A, the across number, and the B, the vertical number. Okay? So here's an example. I'm telling you the initial point, right? The starting point A is at -4, 2. The terminal point is at B, 3, -5. So write the component form. Okay, so we're going to do what it says in this box here. Okay, so I want to know, this is some diagonal, right? Of an arrow in a diagonal, and I want to know how far is it across, right? The A part, and how far is it up and down, the B part. And how do we do that? It's right here. So we're going to take the x's subtract and the y's subtract. And notice, by the way, the brackets are like V shape. That means that this represents a vector. It's not just a point, a vector. So these are the points, right, in parentheses. So I'm going to take these points and figure out the components of the vector. So this is the second point, right? This is the terminal point. So 3 minus -4, there it is, comma, -5 minus 2, there it is. And then the brackets, right? So this comes out to 7, -7. So even though I don't have a picture of the diagram, of the vector, I know that it's 7 across, 1, 2, 3, 4, 5, 6, 7, and then 7 down, 1, 2, 3, 4, 5, 6, 7. So I know the vector, right, points down. Anyway, the instructions were to find the component form. So this is the component form of the vector. What vector? Vector AB that starts at this point and ends at this point has these components. Okay? Now that I know the components, the other thing I can do with the points is find how long, right? The magnitude, how long the vector is. I just found out what A and B are, but how long is the vector itself? Well, if you remember your geometry, from one point to another, we call that the distance formula, and that's exactly what this is. Think about it. So I want to know what the distance, right, the magnitude of V is. So subtract the x's, subtract the y's, square them, add them, and take the square root. This is the distance formula. I hope you remember it, but that's how you find the magnitude. Okay? So if we give you 2 points and you want the magnitude, not the component form, the magnitude, this is what you do. But if we give you a vector in this form, the component form, just 2 numbers, this is a vector. I know it's a vector, right? So what is the magnitude if I give you these numbers? Well, the subtraction is already done for you. So what you just do is a squared plus b squared. Okay, so these are really the same thing depending on what you start with. Are you starting with the points, or are you starting with the components? Okay, so for example, for AB above, we're going to use the same vector above. Find the magnitude, right? So if we use the points, right, it's 3 minus -4. Didn't we just do this? Yeah, to get the component, which was 7, -7. But now I want the magnitude, so I square them, add them, and take the square root. That's how I find the magnitude. The bars, the magnitude. right? That's different from just a vector. 7, -7, I'm done. That's the vector in component form. This is the magnitude of that same vector. It's 9.9 units long. Okay? So, vector operations, very, very easy. Adding, subtracting, multiplying, and dividing. Well, adding and subtracting kind of go together, right? But it's exactly what you think it would be. So, if you have a vector, we'll call it A, and it has these components. And if you have a vector B and it has these components, guess what A plus B is? That's right. You add the first components, you add the second components with a comma in the middle. That's it. Subtraction, same thing. Subtract the first parts, subtract the second parts, comma in the middle. Remember, these are vectors, right? A vector plus a vector gives us another vector. And then if you're multiplying by an outside number, right? If you want, like, say, 5 times this vector, to just multiply in like that. And same thing with division. You would divide. Okay? So, for example, here are 3 vectors, W, Y, and Z. What if I wanted to know what is W plus Y? That would be this vector plus this vector. So that would be adding the first. That would be -4 plus 2, comma, 1 plus 5, right? That's what I did. And this is my answer. So I added these 2 vectors and I got this new vector, -2, 6. What if I want to subtract from Z? Z minus Y? No, Z minus double Y, 2 times Y. So here's Y. I'm not going to subtract that. I'm going to subtract double that. So first let me find out what 2Y is. Here's Z. Here's 2 times Y, right? 2 times 2, 5. That comes out to 410. Now I can do the subtraction, right? Now I can do subtraction. So this is Z. This is 2Y. I'm going to subtract. -3 minus 4, 0 minus 10. And that's my answer. So Z minus 2Y is this answer. Of course, you can skip the middle steps if you know what's going on. It's just adding and subtracting, really. And when you get to multiplying by an outside number, you just multiply just like distributing. Okay, actually that's it for part 1, and it's on to part 2. Okay, see you in part 2. Bye-bye.